Today's video is going to be about energy and specific heat. So first off, let's talk about energy a little bit. So energy is the ability to do work or produce heat. You're going to cover a lot of energy in physics next year. So there are two types of energy. There is kinetic energy and there is potential energy. And once again, you're going to be dealing with both of those a lot in physics next year. Temperature is a measure of the average kinetic energy that is being used. And energy can be measured in joules, calories, or kilocalories. We're going to be using joules in this class. Now, you may be thinking calories sound familiar, that's what your food is from, but your food is actually done in kilocalories. The numbers on our food would be huge if we just did them in calories. The law of conservation of energy states that energy can be converted from one form to another, but cannot be created or destroyed. So we can change energy from kinetic to potential energy, and we can transfer energy to a different source, but it can't be created or destroyed. So the letter Q is used to represent heat energy, and you're going to be using it a lot over the next couple of days in chemistry. So according to the law of conservation of energy, Q lost has to equal Q gained somewhere. So when one object or reaction loses energy, the same amount of energy is gained by something else, whether that's the surrounding environment or another object, varies depending on what it is we're specifically talking about. A reaction in which heat is lost or released is considered exothermic. And a reaction where heat is gained or absorbed is considered an endothermic reaction. Those terms should sound familiar because you dealt with both of those kind of reactions in biology. So let's look at an energy diagram. This is what an energy diagram looks like. You've seen them before in biology, where we have our reactants on one side, our products on the other side, and we look at the amount of energy that was put into it. So how much energy did this reaction start with? So we go over here and we see our reactants, and they start at 80 kilojoules because that's what my unit is here. As far as how much did this reaction finish with, we go over to our products and then trace back here, and we see that it's about 160. As far as did this reaction gain or lose energy and how much, we look at what we started with and what we finished with. Do we have more energy at the end than we started with or less energy? Well, you can clearly tell we have more energy. 160 is bigger than 180. So we gained 80 kilojoules of energy. So based on everything you've seen, is this an endothermic reaction or an exothermic reaction? And in this case, it's an endothermic reaction because it gained energy, which is what we've defined an endothermic reaction as being. Now I want you to try it on your own. So you see our pathway right here in our energy diagram. Up first, I want you to tell me how much energy did this reaction start with. Okay, you should have gotten 150 kilojoules. Found right over here. As far as how much did this reaction finish with, you should get 50, way down here. Did this reaction gain or lose energy, and how much? Well, it lost energy. Our products are lower than our reactants, and it lost negative 100 kilojoules. We put it as a negative number when things are lost. So based on all this, is the reaction endothermic or exothermic? And it is exothermic because we lost energy. Like I said, these diagrams are pretty straightforward, and you've already learned how to do them in biology, so these should be easy points for you on upcoming tests and quizzes. So this brings us to something new for you, to chemistry, and that's called specific heat capacity. Specific heat capacity is the amount of energy required to raise the temperature of 1 gram of a substance by 1 Celsius degree. So if we look at how much energy would it require to raise 1 gram of solid water by 1 degree Celsius, according to the table over here, it tells us 2.11 joules per gram degree Celsius, found right over here. How much energy would it require to raise 1 gram of iron 1 degree Celsius? We look over here, and we see that iron is at 0.45 joules per gram degree Celsius. So if you look at that table over there, which substance requires the most energy to raise 1 gram of a substance by 1 degree Celsius? So we need to find the largest number over there, and you're going to see it up at the top as liquid water. Water actually has an incredibly high specific heat compared to other things, and it's one of the reasons it has such unique properties. This brings us to thermochemistry. Don't let the name fool you, you're going to be awesome at it. So for a pure substance in single phase, you can calculate how much energy is needed using this formula. Q equals mc delta T. I know that seems really overwhelming at first, but once you know what the letters stand for, it's a really easy equation to use. So Q equals our energy in joules. So anytime a question is asking you to solve for energy, Q is what you are solving for. M makes perfect sense, is our mass in grams. C is our specific heat capacity in joules per gram degree Celsius. And delta T is change in temperature. In science, anytime you see the symbol delta, that means change in. So delta T means change in temperature. And you get that by taking the final temperature, the temperature that it finished up at, and subtracting the initial temperature, the temperature it started out at. When energy is released or lost to something else, our Q is less than 0. It is a negative number. And when our energy is absorbed or gained, our Q is going to be positive. So an above 0 number. Let's look at how we use this equation. So you're asked to determine the amount of energy in joules required to raise the temperature of 7.40 grams water from 29.0 degrees Celsius to 46.0 degrees Celsius. The specific heat of water is 4.184 joules per gram degree Celsius. So what variable are we looking for? We are trying to solve for Q, and we know that because it asks us to solve for energy. So Q is always energy. What information do we know? Well, we know the mass of the water, our M, 7.40 grams. We know the specific heat of water. We were told that right up there. We know our initial temperature, 29.0, and we know our final temperature, 46.0. So we know everything we need except for Q. So we can set up our problem by inserting our knowns into our equation. Once again, equation Q equals mc delta T. So we put our mass for the M, our specific heat for the C, and we put our delta T in there. Then we just multiply everything out. Make sure you do the stuff inside parentheses first. So you want to do that subtraction to get it down to one number first. Like I did there. See how I changed that to a 17 before I did my multiplying? And that gets us out this number in our calculator. But because we are still concerned about sig figs, I know, you're sick of hearing about sig figs. And we can only have 3 sig figs because every number, our lowest number in our problem was 3. It is 526 joules, because that's the unit of heat. Not so bad, right? This is basic algebra, solve for one unknown variable. Now remember, I can ask you to solve for M, C, or delta T as well, and you'll just have to turn the equation around to get it on a side by itself. A skill you should be perfectly capable of doing if you've been enrolled in chemistry. So I want you to try 2 questions on your own. Now note, you must show your work to be able to use your notes on the note check. So I want you to solve for, calculate the energy required to heat 454 grams of water from 98.6 degrees Celsius to 5.4 degrees Celsius. The specific heat of water is 4.184 joules per gram degree Celsius. And I want you to solve for a 1.6 gram sample of an unknown metal requires 5.8 joules of energy to change its temperature from 23 degrees Celsius to 41 degrees Celsius. What is the specific heat of the unknown metal? So pause this video and come back when you're finished to check your answer. All right, for number 2, this was just like our example, so it should have been pretty easy for you. You should have gotten the answer of negative 1,770,000 joules. It is a negative number because we lost heat in this case. As far as 3 is concerned, this one you were solving for C. So you had to move your equation around a little bit to get C on a side by itself. But once you did that, you should have gotten that C equals 0.20 joules per gram degree Celsius. How'd you do? Don't leave wrong answers or bad work written on your paper. If you didn't get these right, go back and look at the earlier parts of the video and try the problems again. If you did great, you're done, and I'll see you in class tomorrow.